Hello and welcome back to Shenzen IO. We're going to jump right back into it. This is bring out the Baron. In this level we have to basically create a scorekeeper. So basically it says point and file are simple inputs connected to buttons. So a button will be pressed every time there's a point or a file. Display is an XBus display output corresponding to a numeric LED screen. So this is an XBus connection right here, I guess. The counter should keep track of count starting at 0 and ensure that the display is always showing the current value. When point is pushed, the count should be incremented by 1. When file is pushed, the count should be decremented by 2, but not below 0. So let's just try this one here. This only has 9 lines, so I don't know if we're going to be able to do this. And we'll bring point down to here, into there, and we'll take this over to here. Nice. So now we just got to do like I guess if point is being pressed, this would be come across as a value of 100. We can see it here, so we're gonna have 0 to 100. So let's go ahead and test equal to let's see, we want P1 equal to 0. That'll test if, actually let's do 100. So it's going to test P1 right here, this button here, if it's 100. If it is 100, we're going to put a plus sign down, and we're going to add 1. Next, we're going to test equal to P0 is 100. P0, not PO. P0 is equal to 100. If that's true, we're going to put another plus sign. That means if it's true, we're going to -2. That is not a valid instruction. So I got to look on my sheet what I think it's subtract, not minus. Subtract. Nice. Okay, so then we can, I guess we have to test ACC. Test if less than ACC and 0. Yes, this line TLT ACC 0 will test ACC and see if ACC is below 0. So if it's less than 0, we want to put another plus sign because it only happens if it's true. If it's not true, it'll just skip this line. We're going to say move 0 to ACC. And next up we should just have to, I think, move ACC to X1. And finally sleep for 1. We're going to get to the first point here. Nice, that worked. Score it again. Looks like it's working. See when we get to the next file down here. So there's a file right here in the middle. So let's see if it subtracts 2. Nice, looks like it's working. Let's go ahead and hit the simulate button. Looks like we hit the average on all of them, so that's not too bad. Next up is the rubbish audio thing. We have to design like an audio piece of equipment here, and it says there's a copy of an advert on our desk. So we have to look at the manual we were sent, and we have this thing here. This is our algorithm that we're going to have to include into this thing. Audio out equals audio in minus 50 times 4 plus 50. So I'm sure it's going to come into use once we open the level. But let's go ahead and open it. So audio in is a simple audio input connected to an audio source. Audio out is a simple output connected to an audio receiver. So this is an input, this is an audio out is an output over here. Maximize is a simple input connected to a switch. The signal from the audio in should be copied to audio out. Applying the harmonic maximization algorithm when the maximum switch is on. Look in the supplemental data section of the manual to find an advertisement for that. So let's check out the verification thing. So it looks like maximize is going to be turned on for a little bit, turned off for a little bit, and we're going to have to basically supply some algorithm to this portion of the audio in that makes it look like this. Alright, so we basically have 3 inputs that are simple inputs on pins. So I don't think we have anything that has 3 pins on it. This is P0 and P1. It has 4 X bus ones, but only 2 P inputs on it. So we'll leave that here, but we're going to have to, I think, convert one of these to an X bus. So we could probably like put this one into here, something like that, and make this just test to see if maximize is being pressed. So test if equal to P0 is 100. If it is, let's send out move. I guess we'll do move 1 to X1. And I guess if it's false, if it's not equal to 100, it's going to be equal to 0. So we're going to do a false move 0 to X1. And then we're going to sleep for 1. So I think that'll basically test this to see if this button is being pressed. And then down here we can just apply our audio in to come into here, and this would come out to here. So now we got to do move P0 to ACC so that we can do some calculations on it. I keep typing move instead of MOV. So move P0 to ACC, and we have to, I guess, test of equal. X1 is equal to 0. Let's do 100. It's equal to 100. Then what we want to do is put some calculations down here. X0, it's actually X0, not X1. Nice. Okay, so now if it's true, we want to apply this algorithm to it. So that's going to be ACC. Actually, we can just do minus. Let's subtract 50. I think it was more plus sign. Then we want to times it by 4. So multiply by 4. And then I think it's add another 50. So that's only if it's equal to. If not, we're just going to move ACC to P1 and sleep for 1. I feel like I'm missing something. Let's just try it and see. Yes, we got some errors right here. We're not doing the simple output correctly. Okay, let's reset that. I think what my mistake here is I'm sending 1 or 0. On the X1, I'm not sending 100 or 0. So this should actually be test to see if X1 is equal to 1. I think that should do it. Yeah, looks like that's working now. Let's see if it goes back to normal when we hit the... Yep, looks like it's good. Move this over to here. Grab this in here. This can come into here. This can go out to here, and this can come up to here. And we can just paste this in there because we have less than 14 or 9 lines. So we can just drag this one off, and that should work. We'll get a little bit cheaper. This costs 3, this costs 5. Not that I'm really trying for that, but I'll try to be efficient where I can. So let's simulate it. Looks like we're working. Yeah, so as these get more difficult, I'm going to end up towards the higher end of the spectrum, but that's fine, like we're doing it. So next up, we're going to look at the infrared sensor. This one's quite a bit more complicated, it looks like. Time is a simple input connected to a D25 whatever clock providing the current time. This is the D2415 incremental clock. Basically, this has an index that it outputs a number 0 through 95, depending on what 15-minute increment it is. So that's basically all we need to know, is this outputs a index from 0 to 95. And this is a timer right here, so I guess this matches. So on time is 93, off time is 38 in this case. I'm sure it's going to change as we test it, but that basically tells you when the alarm is on, when the alarm is off. So sensor is a simple input connected to an infrared sensor. So this is connected to a sensor, and when the sensor is above 20, the alarm should be active. So basically, if it's on time and the sensor is above 20, it should output an alarm. So we have a whole bunch of parts over here. These say part not recommended, so I'm guessing it's not like they're not. I think we can use them. They're not locked, but I'm not going to use them unless it says it's recommended, just so we can keep with the basics for now. So we're just going to take this big one for now. I think we're going to grab a signal from here, and basically we're going to just start with the basic, right? We're going to see if we can get it so that this alarm is on if it's past the on time, and shut it off at the off time, and then we'll add the sensor into the mix. So this comes out as a P function, so it's going to be into here. This comes out as an X function, so we'll probably put this one into here. So I guess it doesn't really matter. I don't know if we'll just put these into here for now. We'll arrange this once we get it set up. This is a P function, and I guess this would have to come out to here. So we're definitely going to have to redo this because we don't have much room on the board now. But let's just get it going. So this is going to output a time, an index, right? Either move that index into ACC, or we could just use it directly. Put it in ACC. I think we'll just use it directly. So what I think I'll do is I'll use ACC as our status of the system, whether it's armed or disarmed. So if it's armed, we'll put 100 in there. If it's not armed, we'll put 0 in there. And that way we can have the sensor check the status of the system, and we won't bother checking the sensor if the system isn't armed. That way we're not constantly doing the calculation on the sensor. So let's test this. Test equal. We're going to check P1, see if it's equal to X0, which is the on time here. If it is, we will store, that means the system's armed, we'll move 100 to ACC. And then we will test equal if P1, the incoming time, is equal to X1, which is the off time. If it is off, we will, or disarmed, we will again put a plus in and move 0 to ACC. So that way this ACC will be either 100 if it's armed or 0 if it's not armed. Just delete this. I think we can, I learned that we can actually move the timer, so this will make it a little cleaner. Move the on time up to here. Nice, that should work there. Let's delete this one for now. Next, let's leave it, I guess. Now we need to get something in for the sensor, so let's grab another controller here. Put this into P0, I guess. So let's actually move them off time over to here. I think this will work. Put this into X3. Delete this line here. Let's change that to X3 up here. And that way we can grab this one here and move it into, move this down, move this into X0. And so basically this will sleep X unless it hears on X0. So basically this will sleep until it receives a signal on X0. So over here we will test. Let's test to see if the system is armed. So test equals ACC 100. If it is armed, let's hit plus. Let's move 100 to X0. Okay, so that'll move 100 to X0. So this will be sleeping until it receives 100 from over here, X1. And if this is X0, we will, let's see, we gotta grab P0 and bring this in. Let's test greater than. Test greater than P0, 20, because that's what we want. If the sensor is higher than 20, we want the alarm to go off. If that is true, let's go ahead and move, I don't know if we can move 100 back to, is X1 bidirectional? Let's try it. X0, let's move 100 to X0. I don't know if that'll work, because we're using this two different ways that way. Let's check the information real quick. It says here, when the device is armed and the sensor reads at or above value of 20. So this has to be at or above, so we're going to have to make this 19, because if it's greater than 20, if it's 20 it should still go off. So that's 19, and this is if it's not greater than 20, let's put a negative sign in so it's false. We will move 0 to X0. And over here we'll use another new command. We'll try, so this moves 100 to X0, and again this is armed, so let's hit another plus sign so it's still on the, only doing it on the system armed phase. Let's do a TCP, which is a test compare, and let's do X1 50. So this will compare the incoming X1 value to 50. If it's greater than something, it will, I believe, do true. If it's less than it, it'll do false. So if it's greater than that means it's 100. We want it to send off the alarm, so we will move 100 to P0. If it's false, we want to move 0. Again, I type in move. We want to move 0 to P0 and sleep for 1. This is okay. Reviewing my code, I noticed a couple things. One here, this should be X1. If the system's armed, it moves 100 to X1 right here. So we want that to be a 1. And then this needs try that and see. I think we have to put a sleep in here probably. I think we probably have to put a sleep in here. Let's try it. Sleep 1. Alright, let's advance this and see if this works. So the system's not armed yet. Okay, there the system's armed, but we got some errors messages here. Move 100 blocked on right, blocked on right. Okay, it's trying to execute these at the same time, I guess. So these are not bidirectional, it appears. I thought it would send it down here. But this one executed this one, and it's trying to send it back, and it's not because it's blocked on right. We would have to put this into sleep mode. So I suppose we could add another command in here. This is getting kind of convoluted. 100x1 sleep until we receive something in x1. That should work. And this only happens if this is true, right? I think we want a plus sign here. Let's try that. So that's still not working. Let's reset this. So I'm guessing you can't use these bidirectionally, so let's try something else. Let's just test this and see if it works. Move this over to here. We're going to draw this to x2, which means we need to, that was x0. So x0 up here needs to become x2. And we're going to delete this one. Send it up to here. We're going to move 100 to x0. And then we're going to bring this out to x1. So let's see if that works. That'll send a signal in this way, and this needs to move to x1. Get it to where it's going to be armed. So blocked on right. So I must not be using this correctly. Okay, from what I can tell, it doesn't, like, let's look at this step through here. So we're going to step through here. This is going to send 100 over to x0 over here. Sends it there. This receives it. It's going to check the incoming sensor here and see if it's higher. Right now it's 35, so it's going to transfer 100 to x1. But like, so this never clears, right? So this step is still being executed. This step doesn't clear until this line is cleared, I think. So like, I don't think I can do this. I'm basically creating a circular reference. This is waiting to be cleared, and this can't receive it because this can't move down because this line hasn't been cleared yet. So what I'm gonna try to do is like, let's reset this just to test this to make sure I'm understanding it correctly. Let's just move these to ACC because that would basically let this line complete. It would move back up to sleep, and that would allow this to continue down. So let's try that. Step through it here. So we're saying 100 over. It's checking it. It's going to move 100 to ACC here. Nice, it went back to sleep, and then this should be moving down now. So it's still stuck on that command. Why is it stuck on that command? I guess. Alright, so I think I'm making some progress. If we step through this, this 100 was getting sent over here, but we were never using it, right? It was triggering this, but we never used the 100. So the 100 was just sitting there. So right now I have this set to move it to the ACC just to see if this moves on to the next step. So 100 goes over there, it does move it into here, and that does make this move down. So that's going to target that. It's going to move 100 over to there. See if this works. Nice, so that did compare it. So that moved 100 over, so that's going to send 100 down P0, which should activate the alarm. Nice. So this should turn the alarm off because we're at 6 here. So yeah, it's going to turn the alarm off. Nice. I think we've got it. Nice, that appears to be working. Okay, just out of curiosity, let's see if I change these back to 0. And I change these to 0. If I can send stuff back and forth on this one wire. So that would be TCP X0 here. Let's try that. Yeah, looks like you can do it. That's nice, so this isn't necessary anymore. Okay, let's simulate it and see if we got it. I didn't do too bad. A little bit more lines of code than other people, but we got it done. Nice, that's going to do it for this episode. Thanks for watching. We'll see you in the next one.